Okay, let's get started. Welcome to CSE100, Principles of Programming with C++. I'm your host, Ryan Dougherty. What we're going to basically do today is quickly go over to Syllabus and then show you some things with C++ and get right into the material. So the best way you can contact me is via email. Don't send me a Facebook message. Don't slide into my DMs on Twitter or Instagram. So email is the best way to get in contact with me. I am well known for answering emails almost chaotically fast. So email is the best way to contact me. We obviously meet here Monday, Wednesday, Friday at this time. My office hours are right after class in Brickyard. So the textbook, I'm not sure whether it says required or recommended or whatever on Blackboard, on my issue. I tried to make it so it's not required. It's not required at all. So don't buy the book. It's insanely expensive and you actually will not need it. But I will be going based off of the material in the book via slides that the publisher has given me. So all you really need to understand the material is from the slides that I give you. All right, and so no prereqs, which is good. The TA situation is not completely straightened out right now. For example, Ahmad is not going to be our TA so I haven't had time to update this yet. But hopefully over the weekend I can get who the actual TA is, who the TAs are, what their office hours are, and I'll update that on the main course page, and hopefully you have access to that now. So, of course, you had to sign up for a lab. You signed up for one of these sections. I put a indicator as to what letter corresponds to which lab section. On the main page, I'm going to say this TA corresponds to these labs, this TA for these labs, this TA for these labs. And so if you have questions about the labs, you can contact your TA instead of just all three TAs. Okay, so any questions about this part? Okay, it didn't think so. So the course is basically just intro to programming with C++, getting the fundamentals of how to use C++. So I'm going to get right out of the way and say, I don't like C++. I'm not even joking. I don't like C++. So why do you think I'm teaching a course about C++?
Because it's necessary.
Well, it's actually not completely necessary, but what I have seen is that I thought this class was going to be offered to more computer science people. There's not one computer science person in the entire roster. It's mostly just electrical engineers and biomed people and some other people. So then I realized, well, that's actually kind of useful in those environments where you may want to try to model some system, and C++ is a very fantastic language in those settings. But in fact, I use C++ all the time despite the fact that I hate it. So the main reason is that for my research, I need programs to be very fast. And C++ is a very fast language. So getting that out of the way, what we want is to be able to program in C++ even though it's like shooting yourself in the foot in some sense. So that's basically what the entire course is about. So the course objectives I've listed here. So basically what we're going to do is we're going to go through these one by one. And as we're going along, you'll say, oh, I know how to do that now. I hope you don't expect to know how to do any of these right yet, but we will get to all of these eventually. Any questions about these two? Cool, I didn't think so. Major topics is basically just a rehash of the course objectives, but like in terms of actual topics that we'll cover. So administrative stuff. So of course, I need to be able to give you a letter grade at the end of the semester. And the way that the course is going to run is that we're going to have in-class quizzes, and I'm not going to say what dates those are. So in some sense, those are attendance. But the main part of the course, other than tests, is for be able to program C++. So you'll get 8 programming assignments throughout the semester, and you'll basically be trying to implement some problem that I give you. Okay? So It's basically just problem solving, but programming with C++ as well. But of course, since you signed up for a lab, I want you to actually go to the labs and get help, because learning a programming language, if you've never done it before, is actually quite difficult. How many of you have never programmed anything ever? Okay, so quite a few. So please take advantage of the labs, because they are designed to help you solve a smaller problem than the programming assignments are, but are helpful in trying to solve the programming assignments. If you have no idea what to do on those, the labs can help you get started thinking about how would you actually solve them. And then other than that, we have 4 tests, midterm tests and a final. I've listed the dates here, and I'm very, very sure that these are going to be fixed dates. I'm not going to change them. Partly because one of them, mainly midterm 2, I'm not going to be here because I'm going to a conference. But the cool thing about this is that for the final, if you do better on the final exam, percentage-wise, than the midterm, any of the midterms, then the final test replaces the test where you did worse on the midterms. So this is actually quite helpful in those of you who maybe couldn't get quite started but really ramped up right at the end. That could be really helpful to you. And I don't have fixed cutoffs for grades. I know other professors do. The main reason is that despite what my rate my professor rating says, I'm actually quite a difficult instructor. So I give kind of difficult tests and assignments. So what I try to do is I try to model that based off how hard I think the semester was. So what I'm going to start with is every third of a letter grade is 5%. So A plus is 95, A is 90, A minus is 85, B plus is 80, and all the way down. So that's actually much fairer than some other instructors, but it compensates for the fact that I try to give assignments that challenge you intellectually and be able to show that you really understand the concepts at a deep level. But these can absolutely change. For example, over the summer, I taught one of the harder classes in the CS program, and an A plus was an 85. So just because I have these here doesn't mean that they're actually fixed. Any questions about the assessment? Okay. So please email according to this policy. I say will not be answered, but I get sympathetic and I still answer ones anyway if they don't follow the policy. But it's not guaranteed to be answered. So if you have anything that's like lecture material clarification, things like that, or about the tests themselves, just contact me. Otherwise, if it's about the programming assignments labs, then contact the appropriate TA for that. I don't think we have a UG TA, an undergrad TA, but I may want to get one if there's a warrant for an extra review session or something like that. And then grade appeals is just if you, every student has the right to appeal a grade if you think you didn't get quite as many points as you thought you should have gotten. It's just if you follow this rubric for trying to resolve a grade dispute, then everything will be fine. But just note that the entire item will be regraded from top to bottom if you do. Disabilities. So if anyone has something to do with DRC, disability resources, if you need like extra time on a test or something like that, if you have something with DRC, please contact me as soon as possible so I can make all of the appropriate arrangements. I'm completely happy to do so, but you have to tell me early enough. So I've had a few instances where they told me the day of the test, a few hours before the test, I need to get a test somewhere else. So I'm not likely to be able to accommodate that sort of thing. But if you tell me early, I'm happy to accommodate. Any questions on the administrative stuff? Okay, so my favorite section to talk about, and everyone's favorite to listen to. So what can I really say about this? So before the class I taught over the summer, this number was 2. And over the summer, it's 12. It's actually higher because some of them I didn't actually quite consider violations, but ones that I actually reported were violations. So basically, you can work with anyone you want. and discuss general strategies to solve problems. I actually recommend you do that. Please do that. Talk to everyone in here as much as you want about general strategies to solve problems. But when it comes to writing up your lab assignment or your programming assignment or things like that, that is an individual effort, always, okay? So there should be no, if you're meeting with people, there should be no written materials that leave that meeting, okay? Okay, so the penalties are here. So there's some things like if you plagiarize one thing, you get a 0 and a grade reduction, that sort of thing. So please look at this to be absolutely sure what to do. If you think that you're possibly going over the line, but you haven't submitted it yet, it is absolutely okay to ask me if you think you went over the line because you haven't turned it in yet. So if you have any questions about this at all, please contact me because I really want to make sure that you know what you're doing and whether something constitutes cheating or whatnot. But of course we have wandering eyes, right? We see things on the internet that may help us, but the two things. One is that I'm actually kind of strange in that I don't assign an assignment that's ever been asked ever before. So I try to think of things completely original that you may think, well, my boss might ask me to do this in my programming job at some point. So I try to be applicable, but also try to be original as well. But if you do happen to see something on the internet that will help you, or in fact anywhere else, then if you cite your sources by saying, I saw this on this website, this general idea, and then I implemented my own version of this from this source, please cite the source. There's no penalty whatsoever for doing that. There is a penalty if you just copy verbatim from a source, even if you cite it, because it's not your original work, okay? Okay, yeah, use your own words, that's essentially what I said. Any questions about integrity stuff? Okay, so just a few last things before we dive into the material. So, I can almost swear here, but I won't. Please be ethical in here. Don't be like harassing other students or anything like that. Try to act in a professional and ethical way. Title IX. So if you feel like you're being harassed or in any way, then I have this resource for you, this link right here, to be able to, if you need some outside help or resources to accommodate some harassment or things like that, please visit that link or contact me if you feel like something like that has occurred to you. And then just follow the university policies. Don't like spray graffiti on the wall or whatever. So, okay, here's the lecture schedule. Obviously, there are some things that are not quite filled in yet because I haven't taught this course before, so I don't know how things are going to line up precisely. But I'm very sure that the assignment and the midterm dates are going to be the same. And I'm pretty sure Labor Day won't change or any of the holidays. So the ones in green are off days. The ones in yellow are the test days. And the ones in blue are the assignment due dates. Okay, any questions at all about the syllabus or the schedule or any, yeah?
What's the grading percentage of this class? Like how much is tests, how much is quizzes?
Yeah, so that's up here. So the entire course is out of 1,000 points. Yeah, so essentially quizzes are 10%, 20, 10, 10, 10, 10, 10, 20. Okay? And of course there will be some extra credit because I like giving extra credit for those who really go above and beyond, but this will be the main structure. Any other questions about the test? Yeah.
Yeah. See, I only have like one semester of like basic programming.
Mm-hmm.
Can this class be passed?
Oh yeah, yeah. We're starting from the very, very beginning.
Okay, sweet.
Yeah, yeah, yeah. I remember I have up here no prereqs, so I don't assume anything. Even if you're like an Amish person who's never touched a computer before, I expect you should be able to pass if you put in the effort. So I don't assume anything about anyone, to be absolutely fair, yeah.
Do labs start today?
No, so a great question. So in fact, that'll give me good reason to go to the course page. So on Blackboard, and I think I emailed this too. So this will be the main page for the course. The only reason for Blackboard to exist for this class is to submit programming and lab assignments and to report grades. So you can see how well you're doing at any given point. But the main page will be on this page, which is linked in the Blackboard as well. So this syllabus link, that's just the PDF we just had. The announcements page, I'll be posting announcements periodically there. Please check this at least once. I should say every day, but at least every other day, because I like to post a lot of announcements if there needs to be. So in particular, this one, if you want to actually be compensated for coming to class, then I would suggest to look at this link. But anything involving the announcements will be posted here. They will not be posted on Blackboard, only on here. And then I'm trying to record all my class videos, all the lectures that I do. It's always worked in the past. I'm not guaranteed that a video will actually work, but it seems to be working right now, so hopefully that's going to keep up. At this link, I'm going to have a playlist of all the lecture videos that I post, so if you happen to miss one day, then you can be able to see what thing you actually missed that day. So you don't have to email me, oh, what did I miss? Just check the video. Of course, the TA situation is not fixed yet. We're going to go over lectures in a bit. For all of the items in the class, so all the exams, all the programming assignments, all labs, all quizzes, I'm going to post a sorted grade distribution of every single one. So right over here, I'm going to have a sorted list of about 120 numbers to see what are the grades that have been given for this thing as well as the average. And then you can see how well am I doing relative to the class. I don't curve the grades because curving is evil. So, but just to get a glimpse of how well you're doing. On Blackboard, I have a thing where on your grades, as you're getting things, it'll tell you what your current letter grade is. So according to the one listed in the syllabus. So you can say, oh, I'm getting a B+ right now. Maybe I may want to do better, or I think this is good for me, that sort of thing. And then programming assignments. So all of the programming assignments will be posted here as PDFs. They will not be posted on Blackboard. And then I have the days I post them, or the date at latest that I'll post them. Maybe I post them early. And then the date that are due at 11:59. Can you turn it in at 12:01 a.m.? No. So the good thing is, for all programming assignments, you can submit as many copies as you want. So the ones that are graded are the ones as the last submission that you submitted. But please get a submission in so that you'll be guaranteed that something is graded. But if your first submission is after this, I can't guarantee it'll be graded. Labs, so going back to the question, they start not next week, but the week after. Okay? And of course, some people have days of labs that have either Labor Day or some other holiday, or the days are just off for whatever reason. So what you can do there is, if you can go to any other lab that you want. The only thing is that if the room becomes over capacity, everyone who's not registered in that section has to leave because of fire code, and we don't want to break fire code. Okay, and then the lab PDFs will be posted here too. So, any questions? Yeah.
Are we required to show up to the other labs to get the attendance points, or the attendance points just change?
Yeah, you have to show up to some other lab. It's said in the syllabus, but there are 14 instances of labs, but you only have to do 10. So if you happen to have a day where all 14 meet, you only have to go to 10. You can just skip the other 4 if you want to. Okay, so I only count the top 10 scores on labs. Any questions on the main page? Anything else relevant to the class? Yeah.
There's no labs today.
No labs today, no labs next week, but they start the week of the 27th. Yeah.
On the exams, is the final mandatory, or you can?
Well, I mean, it's technically not mandatory, but but it's just you won't be getting any of those points. Yeah. So I know some people have the finals not mandatory, but the way I compensate for that is that it replaces earlier tests if you did better on the final. Because the final is going to be comprehensive, so if you show that you knew more on the test that covers everything than the tests that cover only some things, then it seems to make sense to replace the things where you didn't do as well. Other questions? Yeah.
I saw that you were talking about applications like MATLAB. Are there any other applications we need to download on our own computer?
We're about to get into that. We'll get right into that. Yep. Other questions? So let's launch right into that. So the way that you'll be submitting assignments is by submitting C++ source files and some other files as we go along. So there are bazillions of ways for you to be able to write your C++ program. So I'm going to show you two, but there are many others. If you cannot set up your environment, I and all of the TAs are very willing to help you set up your environment as soon as possible. So if you can't set it up by, say, this weekend, then please, please, please come to office hours. We are willing to help you set up your environment if things won't work. So the one that I like to use, actually not really, but the one I recommend a lot is called CLion. So CLion is not free, but it is free, not if you torrent it, please don't do that. But it is free with an educational license. So if you, I think if you sign up with your ASU email, then you get a license for X years for using CLion. So, and then we'll go into how to actually make a project here. The other way that I actually use it more is to use a text editor and a terminal or something like that. So I use Sublime Text. It's just a text editor. But the way that we run the programs is by using a terminal. If you have a Mac, this already works. So you don't have to do anything to do this for Mac, but it's a little bit more challenging for beginners to actually use it this way. If you have Windows, there is something called Cygwin, C-Y-G-W-I-N, that allows you to install everything related to C++ on your environment. But there are what are called IDEs, integrated development environments, that we'll talk about in a bit, that are like CLion, but are available on all platforms. So for example, CLion is available on Windows, Linux, and Mac as well. There's a Visual Studio for Windows. There's many others, like Code Blocks. I can recommend many more. But any of those environments is perfectly okay. Any one you want. So I'm not going to say this one is required. You can use anything you like. So whatever you're most comfortable with. Does that answer your question? Okay. Any other questions? Yeah. Yeah. That's actually a good thing. So send me an email. I can put an announcement about that. Because I might not remember to do that. So if you send me an email, then I will. Other questions? Yeah.
Besides you, who else could we go to help us set up this program?
All three TAs. So Ahmad is not going to be here, but Kuntal and Jianfeng will be definitely here. There's one more TA that we're still trying to set up office hours for. Yeah.
And, when do we need to set this up?
So the first assignment goes out on the 24th, so hopefully by the 31st.
Okay, that's plenty of time.
Yeah. So, but it's just that for a beginner, it may be harder than some people who have already set it up. But we're absolutely willing to help. I could, if there's warrant, I can even make a video about setting it up. So if you think that's a good idea, send me an email, and then maybe I can do that. Other questions? All right, let's dive into material. Hopefully this works. Yeah, sweet. So just as a note, I like using all of the minutes in a lecture. So if I go to 9:25 and I am over time, please tell me to stop because I just like rambling on over and over about certain things, but maybe this will help. Okay, so if we want to be able to program in C++ or other languages for that matter, what we need to do is to understand, well, why do we program in the first place? Why should we even care? Why is this class even here? And then maybe after that, maybe if we can answer that question, we can ask, well, if we're going to be programming for these computers, or any device for that matter, then how do they work? So if we try to understand how they work, maybe we can get a better understanding of how do we actually program? How do we try to design our programs to work best for the computer, or maybe for a user if there happens to be a user of your program, all that stuff. So why do we program? Well, the computer itself is just a machine that you can program, that people have written many programs for, that just follows instructions. The computer is not smart at all. So many people are saying like AI is going to take over the world or things like that. The computers that run them are just completely dumb in some sense. They just read instructions that are fed to them via some programmer, and then the computer just executes them blindly. It doesn't make any decision whatsoever. So it doesn't make decisions like we do, but the great thing about computers is that they're much, much faster than we are at being able to do calculations. So if we can have a computer do these complex calculations that we can't do ourselves very efficiently, then that would be a very good thing. So a program or software for that matter is just instructions written by someone that the computer just follows to perform some task. So we write a program, then we convert it in some way that the computer can understand because the computer's dumb. It doesn't understand English or any spoken language. So once we convert it over to this format that the computer can easily understand, then we can just feed it to the computer and it just completes the task and then gives us a result if we want a result. Then obviously there's a person who actually programs the computer because the computer can't program itself because it doesn't understand decision making, right? So the programmer designs the programs that the computer will actually execute. So we'll actually show a program in a little bit. So we need programmers, hence why this class exists, so that we can make programs to have computers do tasks. Okay, but of course, programming is an art and a science in a certain sense. So there is a little bit of artistry in programming because if a user is going to be using your program, then they want to actually be able to use your program easily, right? If you have a complex user interface, then it could be difficult for the user to actually use it, right? So if you try to organize how the components are laid out or how the program actually completes the task, then that could be a decision that you make when designing the program. How do you even display the information, right? So if you try to use Comic Sans in bright cyan format, bright cyan color, then the user may just say, oh, Comic Sans, I hate Comic Sans. Do we all hate Comic Sans? Yeah. Thank you. So, it's very important how information is displayed. Fortunately, in this class, we won't have to worry about this item because all we're just going to do is have textual communication, just plain text between the user and the programmer. How the user even interacts with the program, that's also important. But the science of it is that we need to understand, well, how do we even have this language in a certain sense to convert it over to a format that the computer can understand? So if we understand how the language operates, then we can actually understand how do we actually make a program that the computer can understand. And then of course, as we all know, there are many bugs in computers, right? In all software. So you hear in the news all the time that someone found a security bug in iOS or Android or something like that. So if we understand how to test our programs to make sure that they work, then we can actually understand, well, the computer just blindly runs this thing. It doesn't know, oh, there's a bug right here. What you do is you try to understand how to run it in C++ to be able to have the computer run your program correctly. So let's see, a program. So what I have here, so where are you? I guess I don't have it open. Okay. So here's a sample C++ program, and we're going to go into all the details about what each and every single one of these lines actually means. But just for now, by looking at this program, just purely observing it, what do you think the program does? Well, I see a 5 here. I do, but we don't understand what this double thing is. Num1, well, I don't know what that means necessarily. I do see 12 here, and I do see an addition here. Well, this equals kind of looks like I'm checking for equality here. So, but I'm doing something like, well, whatever this cout thing is, and then, well, I see the sum is, and then some more weird text, and then I reference, oh, there's the sum from earlier that was in the calculation from earlier. So what do you think the program does? It looks like it does addition, right? So it seems like, well, 5 has something to do with num1 over here. 12 has something to do with num2. And if I do addition of that, well, what is sum associated with now? Adding. So what is 5 plus 12? 17. Hopefully it's not that early that we can't do that kind of arithmetic. So it seems like, well, the sum is, and then maybe we're outputting 17 as well. So in CLion, this icon over here, this little green arrow, that's to what is called compile and run your program. And we'll try to understand what compile actually means. But if we just click that, then we see, oh yeah, it actually does output the sum is 17. If I change this to 212, what do you think if I run this again, the answer will be? 217. And in fact, we see that's the case. Okay, so it seems like, well, this cout has something to do with outputting to this, what is called a console. So all this right here, where we're actually outputting stuff, this is what's called the console. And cout seems to have something to do with actually outputting to the console. So this is the interface that we'll be doing with the user. So if the user has to enter something, it'll be through this interface, and then the program will wait for the user to enter something, and then if it needs to output something, it'll print it to the console. Okay? Any questions on a high level what this program does? We'll get into all the details in a bit. Yeah? What is the what? We'll get into all the details, but it's just the high level. What is this? Do we understand what this program does? Okay, great. So let's get back into this. Okay, so we talked about this. So the computer itself is a combination of hardware and software. So can anyone tell me what hardware actually is? Yeah.
Like the monitor.
Right. What about, like, say, the hard drive in a computer? Is that hardware? Yeah. What about the chassis on the computer? The display, all that stuff. So it's the physical components of the computer. So anything that has the physical device right here, anything that's the physical part of the device, that's hardware. Okay? More commonly, people associate hardware with anything that has to do with, like, say, the logic board in the computer. So the logic board is where all of the magic happens in some sense. So, like, where it processes these instructions, or it tries to output to the display, things like that. But of course, there are categories for which hardware can be assigned. So the main one is the central processing unit, or CPU. So the CPU, we're going to get into the CPU in a second, but the high-level idea of a CPU is that it processes the instructions that you feed it via your program, and it'll do a certain action based off what it sees. So if it says, well, I see this number and I see this number, and the instruction is add, then the CPU will carry out the instruction adding for you, or maybe subtracting or multiplying, that sort of thing. So the CPU is responsible for processing the instructions that your program has. But if you want to actually run your program, you need to be able to store it somewhere so that the CPU can read from your program's instructions. So that is what is called main memory, or another term for it is RAM, or random access memory. And we'll get into that in a bit too. But so what happens is your program is initially sitting as a file on your hard drive or solid state or whatever. And then when you execute the instruction, run my program for me, then what's going to happen is your program is going to be transferred into main memory, where it'll actually be read by the CPU by just reading the instructions of your program. And then maybe a certain thing happens, maybe it terminates, maybe it runs forever, that sort of thing. But in order to actually store your program somewhere, we need secondary storage devices like your hard drive or an external drive. Why don't we just say, oh, we can just use main memory for everything, right? It's going to be transferred to main memory anyway, so why can't we just use main memory to start with? Yeah. Right, and we'll get into that in a bit, but it's what is called volatile. So main memory is volatile in the sense that if you turn off your computer, then main memory is wiped out. Okay? The main reason why you want this to, why this occurs is that by having this volatility property, we can guarantee that main memory is far faster than accessing it from your hard drive. So if we keep the program on the hard drive, your program will run, I'm not joking, 10 times slower than if you put it in main memory. So there's a great analogy that I've heard that if the amount of time for the CPU to access something in main memory is represented by a coffee break, what do you think is the analogous amount of time to access something on your hard drive? Oh, way longer. I've heard it's like a sabbatical.
Go into bed and wait for your parents to make coffee.
Yeah, way longer than even that. But yeah, so secondary storage devices are mainly so that you can store a lot of things, but for long-term storage. So it's not volatile like main memory is. But we'll get into all that later. But in order to actually have your program say, well, I need something from the user, I need a file or I need some information from the user, I need to be able to input from somewhere. So what are some input devices on a computer in general? Yeah. Keyboard's one. What's another one? Mouse. What's another one? Yeah. Microphone. Another. Camera. Yeah. So or even through some Ethernet connection or somewhere. So anything that the input comes from somewhere outside the computer into the computer, into either secondary storage, main memory, or the CPU, those are input devices. But as you might expect, there are output devices too. So an output device is the display itself, or maybe it sends a connection out to somewhere else, that sort of thing. Any questions on hardware? Okay, so just to reiterate, the CPU lives in the middle along with main memory. So those are the main things that we need to consider for running any program at all. But we have ways of accessing either through inputs or outputs. So a lot of input devices here. Secondary storage devices are great because they're both input and output devices. So if you want to save to a file, as we'll do later in the semester, then you want to save that somewhere, and secondary storage is a great way. But output devices, a printer is also an output device, or even speakers. So there's a lot of things that you need to be able to consider when designing your application. What types of input devices do I want? What types of output devices do I need to consider? What is the structure of the CPU? What is the structure of main memory? How much main memory do I have? What is the size of my hard drive? You need to be able to consider all of those things in designing your programs. So let's try to understand this CPU, because it seems like it's at the core of anything that we do when we try to program something. So it's obviously, as I said before, something that just runs your programs. You feed your program in some format that the computer understands, and it just reads the instructions, and it executes, and maybe outputs something, that sort of thing. But the CPU is just not a complete isolated unit. And this is not true in general, what I'm going to have here, but it's mostly true for most computers. So there's what is called a control unit. And what this does is it receives an instruction like add these two numbers, and it decodes it to be able to say, oh, well, once I get this instruction, I don't necessarily know what it does. So this control unit says, oh, I see that these parts of the instructions are add, and these two parts are two numbers, and so, yeah, now I know what to do. I need to be able to add these two numbers and store them somewhere. And it coordinates operations of the computer, as you might expect, because it decodes all of the instructions. But there's what is called an ALU, which is an arithmetic and logic unit. So the CPU, for the control unit's perspective, is to be able to understand what the instructions are actually doing. But most of the time, we're going to be doing some kind of add or subtract, multiply, divide, that sort of thing. So we should have a specialized unit that runs really fast for those types of instructions. So the control unit, when it sees those kind of computational types of instructions, forwards it over to the ALU, where the ALU can actually do the fast calculation for you. So it performs the math operations. And this is basically, at a high level, how it operates. So it receives an instruction, and then the control unit can forward things to the ALU, and then maybe the ALU can say, oh, the result is this, and I stored this at this place in main memory. Then it needs to forward that over to the control unit to be able to store that into a particular memory location. So the control unit is responsible for other operations as well. So maybe I need to store 217 in this place in main memory so that the program can access it at a later point. Which is what we saw earlier, where we stored the value 217 in this, what is called a variable, and we'll get into those in a bit. And then we saw, well, we had this cout thing, and then we accessed the same variable later. So the fact that we stored it in this memory location, we need to be able to access it at a later point. Any questions about the CPU? Okay, so how does the CPU actually work? So it seems like it has to decode these instructions and then do something with them. So there are three main parts that a CPU actually does. So the first one is fetch. So it has an instruction that it has seen before, but it's already processed this instruction now. Now it needs to move on to the next instruction. So what does it actually do? It needs to say, well, I accessed this instruction in main memory before. Now I need to access the next one. So then it looks and says, well, maybe it's at the next memory location or at some other place. There are some instructions that involve going to somewhere else. So one of the responsibilities is to say, well, what's the next instruction? Okay, so that's part of the fetch step in a CPU. But then, as we know, we need to decode the instruction once we get the instruction, and then we need to execute the instruction. So the control unit and the ALU are responsible for those things. So, and then it just repeats. Once it's done executing, it fetches the next instruction if there needs to be one to execute. Then it does decode, execute, fetch, decode, execute. and then either the program completely stops, or via a stop instruction, or it just runs forever through this process, or the computer blows up or turns off or something like that. Okay, any questions on this, how the CPU works? Yeah.
So what's your favorite program? What type of program do you like to use the most?
Python is one of my favorites. But C++ is the only really use I have for it is to make it programs run quickly. But Python is another great language. Yeah. I can't hear you. Sorry.
You said that the CPU doesn't really understand the languages we type in our input.
Correct. Mhm.
So how does it decode the structure?
Great question, and we're about to get into that. What's sorry? How do you what? I'm rusty on it. I'm rusty on the programming language Rust. Yeah. More awful jokes to come in this semester. So, but yeah, I haven't really used Rust very much. But any other questions about this stuff? We'll get into all the details about the decode step and how to actually convert this C++ program into something this recognizes. Okay, so, but to understand how the programs actually run, we need to understand what main memory is. So, of course, we need to have instructions in main memory, but of course we may have data as well. So what's an example of a type of data we may want to process in a program that we write? I'll get you started. What about an image? So we may want to store an image into main memory. What else could we want? Yeah. Raw text, yeah. Yeah, any kind of data that we want. Sound, data, sound, text, images, anything we want, we need to be able to store it in main memory. Because the program, when it executes, looks into main memory first. So we'll talk about why that is. But it looks in main memory first and says, oh, do I have this particular data right here? Then if I do, then I can process it. And as I said before, the main memory is volatile, so it destroys itself when the computer is turned off. There's nothing kept in main memory, although that's not completely true, but it's mostly true. It's called random access memory because you can access any location in memory at all. So you don't have to access the memory in a specific order or something like that, although there's a good reason why you should. But the thing is, it's the random part here means you should be able to access any location in memory, and it should take about the same amount of time. So the great thing about RAM is that you can say, well, I stored this big image file over here, and this program's over here. Then what RAM guarantees us is that if I'm processing instructions over here, then if I simultaneously jump over to here and try to access the image, that should take about the same amount of time. Although that's not completely true, and we'll see why. But it's mostly true. But how is main memory even organized? So if we want to store things in main memory, well, what things are actually stored there? How do I write this program into main memory? How do I store this image file into main memory? What about video? Things like that. So the main thing, as you probably have heard before, something called a bit. So what is a bit?
It's like a quantifiable storage space.
Right, so it's quantifiable. So what are the common values? Yeah. 1 or 0, yeah. So it's the smallest piece of memory that you can't decompose further. So every bit is kind of like an atom well, actually that's not true either. So it's like a quark in an atom, but for the physics people out there. But it's the smallest piece of memory. It's binary digits, so where the bit comes from. For the electrical people out there, it represents an electrical charge. So when I try to read some bit by the CPU, the way it reads it is it says, well, is it at this voltage level or at this voltage level? Okay? That may be completely wrong, but it's what I understand it to be. So it's an electrical charge, but we can think of it as a 0 or a 1. Any other questions before we... Great, I'll see you on Monday.